So now that I've given you an overview of the scheduled executor service and talked a little bit about how you can have an implementation of said scheduled executor service with the scheduled thread pool executor class, let's talk about how we can actually apply this particular capability in practice by discussing the design of a so-called timed memoizer. And we'll see how a timed memoizer is going to be able to apply the scheduled executor service and the implementation therein in order to be able to remove stale entries. So if you recall, our memoizer was used to map a key to a value that's produced by a function. But the problem there was you could end up having there become a very large cache of these elements. And if those elements aren't needed, then we really would like to have some way of being able to purge them periodically. So we're going to implement something called a timed memoizer, which also maps a key to the value produced by a function. However, unlike the regular memoizer, this timed memoizer is going to limit the amount of time that a key value pair remains in the cache. And the whole thing is going to be, of course, whether or not it's accessed within a certain time period. So just a quick recap for consistency and completeness. Recall that the purpose of the memoizer in general is to return a value that's been previously computed by perhaps a long-running function rather than having to recompute that function again. So it's basically a cache. Time memoizer, like our previous memoizer, uses concurrent hashmap for all the same reasons we've talked about before. If you recall that concurrent hashmap allows you to have all these different, or it internally uses different locks for each of the bins in the hash table so that there's very little contention, whereas the synchronized maps have a single lock, so therefore there's a lot of contention, or potentially a lot of contention. And there's also, of course, in the concurrent hashmap, this really cool compute if absent method. Now, in this particular case, we're going to assume that we're using Java 8 and beyond, therefore we can take advantage of the compute if absent capability. If that was not the case, if you were stuck with earlier versions of Java, Java 7 or before, then we'd have to use our future task implementation that we looked at in a previous lesson. So here's the idea, the basic concept behind the time memoizer. If a given key in the map, if any given key in the map is not accessed within a designated time period, then the timed memoizer will automatically purge it from the map. And the way that this is going to work is we're going to have an internal implementation called a RefCountedValue. And RefCountedValue, as you might expect, will be the type of the value in the concurrent hash map. And RefCountedValue is going to track the number of times that a key is referenced within a given number of milliseconds. So essentially, if something is not accessed in that time, the reference count is not increased, then it's going to be a candidate for purging. And the way we're going to do this is we're going to have a runnable, which we'll look at when we explore the implementation in more detail in the next part of this lesson, called RemoveIfStale. And RemoveIfStale will essentially use the logic for timeouts to go ahead and remove the key value pair if it is not accessed within the time frame designated by the given period. And of course, the whole point of this is to demonstrate the Java scheduled executor service. So it's going to use the scheduled executor service in order to do this purging based on the passage of time. So each runnable is scheduled as a one-shot task that's rescheduled if and only if the value has been accessed during this period of time, which we designate as M timeout in milliseconds. So if something is accessed in that time, it's going to be rescheduled so it can run again and keep trying till it is not used. But if it's not used, then it's going to be purged. Now, the downside with this particular approach, it's going to work and it's going to solve the problem of purging things. However, if you have a very, very large number of key value pairs, then you'll end up having a RemoveIfStale runnable for each key value pair. And that can become overly expensive. And so I'll show you how to do it with this particular approach, but then we'll come back later and show how to do this with just a single runnable that will be used to handle all the entries in the map. So that approach is arguably a bit more scalable from the point of view of space utilization. So we'll talk about an extension to timed memoizer later that uses periodic timers to solve this problem. So that's the end of our overview description about how we're going to use the Java Scheduled Executor Service in order to implement a timed memoizer. This is just to give you the big picture gestalt view. What we're going to do now is we're going to kind of dive down into the implementation and see how to implement this particular capability using Java and the Java Scheduled Executor Service.